Hello everybody, and welcome back to another episode of Math with Mr. Emond. Today we're going to be continuing on in our unit on absolute value and reciprocal functions, but we're going to be focusing in today on absolute value functions. Let's get started. The first thing I want to kind of do here is make two graphs. One graph is going to be for the function y equals x, and we know how this looks, right? It has when x is 0, y is 0, and it has a slope of 1. So we can just, graph these points here. And we end up with a straight line, and of course they go in the other direction too. We end up with a straight line, and it looks something like this. All right, so we're gonna go all the way up to this corner, and then down to this corner. And you can see it goes through all those points, and there we go. There's our function, y equals x. Now what happens when we graph y is the absolute value of x? And the interesting thing that happens is we know that when you have a function, y equals absolute value of x, that all of these x values become positive, right? So let's say if x was -2. If x was -2, what would y be? Well, on your normal graph, that would be -2. But now when I plug in x is -2 over here, we can see that y will actually be 2. And so what happens is all these negative values become positive instead. So instead of -2, it's +2. Instead of -1, it's +1. And what happens is, hopefully you can see that it actually creates a mirror. And it's mirrored on the x-axis. So let's go ahead and graph this one. Okay, so we're going to start at the origin, and it's going to go all the way up to this corner, going through those points. And then what does this side look like? Well, it looks exactly like the y equals x. So they're identical from 0 to positive infinity as x values. It's identical. So in this case, they are exactly the same. And this is y equals the absolute value of x. Okay? So now we have a little bit of an intro. When you're graphing the absolute value of your original function, all the negative y values become positive y values, and that's basically how we're going to graph it. So let's look at this for a table of values. In this case, we have f of x equals 2x plus 3. So f of x is going to be our original function. Let's make a table of values for this. When x is -4, I'm just going to type this in the calculator so everybody can see. When x is -4, we're going to have 2 times -4, and then we're going to add 3 to that. And that's going to be -5. So y is going to be -5. When x is -2, we're going to have 2 times -2 plus 3. So 2 times -2 is -4 plus 3 is -1. 2 times 0 is 0 plus 3 is 3. And then this is going to be 2 times 2 plus 4, so 7. 2 times 4 is 8 plus 3 is 11. So there we go. I stopped typing them in my calculator because these are really easy calculations, right? Now let's look at g of x. So f of x is our original function, and in this case g of x is going to be equal to the absolute value of f of x. And what was f of x? F of x is equal to 2x plus 3. So on the inside here, I'm going to say 2x plus 3. And so now we can kind of see what they're wanting us to do, which is graph g of x, which is the absolute value of our original function. And what do we know? Let's look back here. The x values are the x values, right? When x is -1, x is -1. Those don't change. But what happens is when you plug in that negative x value, it becomes positive as a y value. So our x values will be the same, but our y values, whatever it was, is going to be positive now. So we know that 2x plus 3 is -5, and the absolute value of -5 is 5. -1 becomes 1. 3 is already positive, so it stays the same. Same with 7 and 11. So there we go. Using a table of values, we can see exactly what's happening here. When you do the absolute value of your original function, only the y values change, and they go from negative to positive. Okay. An absolute value function is a function that involves the absolute value of a variable, just like we saw. And remember, absolute values are always positive. So when you do the absolute value of your original function, you should never have negative y values. Let's take a look at these graphs. We have a bunch of different lines here, and these lines are for different f of x values. Now, we don't know what those are, right? I mean, we could probably find it pretty quickly. This has a slope of 1/2, right? It's rise of 1, run of 2. So it has a slope of 1/2. And what's the y-intercept? It's 1. And so we know we have the skills to do this really easily. Like, we can find the equation if we want to. And then we could make a table of values for this. But why are we going to do more work than we need to? All we're wanting to do here is graph the absolute value of the original function. Graph the absolute value of the original function. Well, here's my original function. And I know the only thing that's changing is whenever I have negative y values, they become positive instead. So let's do that. So it's from this point, from -2 and below that, everything less than -2 is going to be negative. So this point's the same. Okay. At x equals -3, y equals -1/2. So we need to make that positive 1/2. So there we go. And at x equals -4, y is -1, and so that should be positive 1. So you can see they just get reflected. And now, of course, we can do our graph, right? Let's get started on that. So here's our graph going through those points there. And of course, these are exactly the same. And there's our absolute value function. Looks like a V, shifted to the left. All right, let's go ahead and give this one a shot now. So again, I don't need to find the equation. If I wanted to, I could. It's very easy to do that. But let's just take the shortcut. So we know there's where we're crossing the x-axis. Everything to the left of this point that has positive y values, they're going to be exactly the same. So actually, why don't we just go ahead and draw that part of our graph? It's exactly the same. There we go. Now, we have to kind of be careful here. So I'm going to be looking for points that are easy to read. So like this one. When x equals 2, y is -2. So now this -2y value is going to become positive 2. So it just gets reflected. Here, when x is 3, y is -4. And so I can, again, graph that one. And it's right there. And so now I have my 2 points. I can go ahead and graph my line going through those points. And there we go. There is my g of x. And of course, I can be good here. And I'm instead of saying y equals absolute value of f of x, I'm actually going to change this into g of x is equal to the absolute value of f of x. And so what this is saying is my second function, g of x, is the absolute value of my first function. So I've graphed my f of x, that's what was in blue, and now these new ones are, I don't know why I did that. These new ones are, I'll write it over here so it's not so crowded. In green is g of x. Okay. In green is g of x. Now let's do these ones. So here's where I cross the x-axis. At 0, it was -3, so now that's +3. At -1, it was -5, so now that's +5. Let's make our graph going through those points there and there. There we go. We have graphed our functions. Let's move on. So we're going to look at the first example here. We're graphing an absolute value function of the form y equals the absolute value of mx plus b. Now, mx plus b, this is a linear function in slope-intercept form. Perfect. So we're going to consider this one, y equals absolute value of 2x minus 3. And we're being asked to state the x and y intercepts. So I'm gonna actually split this up into two different functions, okay? So the first function of x is going to be just 2x minus 3. So this is y equals 2x minus 3. The second function, of course, is going to be the absolute value of that first thing. So g of x is equal to the absolute value of that original thing. Now let's figure out what is my y-intercept here. So this is really easy. My y-intercept is when x is 0, so y equals 2x minus 3 when x is 0. That means 2 times 0 is 0, minus 3 is -3. What's my x-intercept? Well, my x-intercept is when my y is 0. So this time I'm going to have 0 equals 2x minus 3. I'm going to isolate my x, so I'm going to have 3 equals 2x. And of course, finally, x equals 3 over 2. Or in other words, x is 1.5. All right, I'm going to go ahead and erase this. And over here, just write 1.5. Okay. One thing that I want you to understand is when we look back over here, did our x-intercepts ever change? No. Our x-intercepts are always going to be the same because your x-intercept is actually the point where there's going to be a reflection beginning. Now, are my y-intercepts the same? In this one, my y-intercept was the same. In this one, it was. But what about this one? My y-intercept was -3 here and +3 here. So my y-intercept is the one that changes. And that's because my x values are the same, right? Here, at this point, my x value is 0. At this point, my x value is 2. For both of them, this point is 2, comma 2, and this point down here is 2, comma -2. So my x values are the same. It's my y values that are changing. So my x-intercepts are always going to be the same. So I can say here with certainty that my x-intercept for g of x is going to be exactly the same. What's my y value going to be? It's going to, why did I change it to purple? I shouldn't have done that. My y-intercept is going to be the absolute value of my other original graph's y-intercept. So it was -3, now it's 3. So that's all you really have to do is apply that little piece of understanding there. Let's go ahead and graph them. So let's start with our original function, f of x, which is just a line, right? It has a y-intercept of -3 and an x-intercept of 1.5. So here's my x-intercept of 1.5 and my y-intercept of -3. What's my slope? Well, it's 2x minus 3, so my slope is 2. So I can see with a slope of 2, I'm going to have to rise by 2 and run by 1. Rise by 2 and run by 1. And you can see how that x-intercept falls exactly perfect in there. Rise 2, run 1. Down 2, left 1. So there, I think we have enough now. We can go ahead and graph our line and we're going to make it purple. Okay. Scroll down a little bit and let's find our corners. Down 2, left 1, down 2, left 1. Okay, down 2, left 1. So I'm just going to go to this point. And we're going to go up. There we go. And we can label this. This is f of x. So we have graphed our original line to x minus 3. Now, how do we graph our line for the absolute value of that? And you should be saying, actually, Mr. Emond, that's not that difficult. Really, the only thing that's changing here is from this point, anything that's negative is now positive. So here we had 0 and negative 3. It's going to become 0 and positive 3, right? And we're going to continue from there. Kind of moved in the last minute, but it looks pretty good. All right. And of course, this is exactly the same. So there we have our v. So we have graphed it. State the domain and the range. Now, hopefully you remember there's multiple ways to write your domain and range, right? We're going to have to do this for f of x and g of x. So the domain for f of x is x such that, let's look, it goes on forever in the left direction here and on forever in the right there. So this is going to be from negative infinity, x is going to be greater than that, and x is going to be less than infinity. And x is all real numbers, okay? Our range is similar, right? We're hitting every y value in the negative and every y value in the positive. So y such that we're going from negative infinity, y has to be greater than that, and y has to be less than infinity, and of course, y is all real numbers. Okay, make a little bit of room here, move this down. Let's do our g of x. So our domain for g of x, let's look at it. It goes on forever to the left and forever to the right. So our domain is x such that, and it's the same. It didn't change. It's going to be greater than negative infinity and less than infinity, and it's going to be all real numbers. Okay, what about our range? Well, now we can see in green here, it never drops below 0. So it's from 0, and it can be equal to 0, to positive infinity. So our range is y such that it can never go below 0. So x has to be greater than, y has to be greater than or equal to 0, but y has to be less than infinity. And of course, y is all real numbers. Okay, now for part D, we're looking at expressing it as a piecewise function. So you're going to do this for g of x. And how this is written is you're going to say y is going to be equal to, and then you're going to create two different expressions here. So first we're going to say that for g of x, it's going to look exactly like f of x. So f of x is 2x minus 3. We're going to say g of x is going to look exactly like 2x minus 3. When? When do they overlap? It's here. It's in this region. I'm going to highlight it for you. So they're going to overlap in this region here. They're exactly the same function. And so we can then go ahead and say that y is going to be equal to, it's going to look exactly like 2x minus 3 if x is greater than, because this happens greater than when? 1.5. If x is greater than 1.5, it's going to look exactly like 2x minus 3. Now, what happens when it's not? What happens when it's less than 1.5? Well, then we have two different sections. Do they look exactly alike? They do not. This and this do not look exactly alike. In fact, they look quite different from one another. And so what would we say in this case? Well, we would have to find a way to say that it looks like 2x minus 3 if all those negative values became positive. So how do we write that? Well, you say negative 2x minus 3. So if this value, for example, if 2x minus 3 equaled negative 3, well, if you do negative times negative 3, that makes it positive 3, which is what it is up here. So by saying negative of our original function, we are turning all those values positive. So g of x is going to look like the negative of 2x minus 3 if x is what? Less than 1.5. And so what happens in this point? Well, you know, at this point they're the same, right? So it really doesn't matter. You could put those if you want, because it's not going to make a difference. Because 0 can't be positive or negative, right? So there you go. Let's move on. All right, it's going to be your turn. Go ahead and pause the video now, work out your solution. You're going to have to do a little bit of graphing and come back when you return. Okay, welcome back. Let's take a look at the solution. So I started off by splitting up my equation into two functions, f of x without the absolute value sign and g of x with it. Now, finding the y-intercept, you just plug in x equals 0 and you'll find it's negative 1. For the x-intercept, you plug in y equals 0 and you'll find it's 1/3. And remember, it's just like the previous problem, your x-intercepts don't change. Your y-intercepts become the absolute value of that first one. So before it was negative 1, now it's positive 1. And that's it. So we can use these points now to help us graph. So we have the x-intercept here at 1/3, and we have the y-intercept of our original function at negative 1 there, and positive 1 for the green function there. And now we can kind of continue graphing. So we know that the slope is 3. So on our normal function, if this is our y-intercept and we go up 1, 2, 3 and over 1, we'll find this point, 1, 2, 3 and over 1 there, and then here, and so on, and another point there. And you can use these points to graph your line 3x minus 1, okay, which is this purple one. This is 3x minus 1. And then when you take those negative values over here, all of these negative y values, and you turn them positive, you end up with your g of x function graph, which looks like a V highlighted there for you. And so there's your two functions, f of x and g of x. Hopefully yours look very similar to that. Your domain, what you should be noticing here is that your domain and your range for your lines are exactly like they were in the previous problem, and they will always be an element of all real numbers. Your range, again, is on the g of x going to be the only thing that's different, and that's because there's no negative values. So it's from 0 to infinity. Now for your piecewise function, what you should have written for your g of x is that y is going to be equal to your original function if it's equal to, greater than or equal to 1/3. So anything greater than or equal to 1/3, which is this region here, you can see the purple line and the green line, they're on top of one another, they're equal to one another. So when x is greater than or equal to 1/3, g of x is going to look exactly like f of x. That's what this says. Now in this section, these values come by taking the f of x values and making them positive. So here's my f of x values, which we know are negative when x is less than 1/3. And so we could say by making them positive, we now have the second piece. So we write that as negative times our original function, which is going to make them positive, if it's less than 1/3. And there's your solution. Let's move on. Let's try this out. So we are going to be looking at graphing now parabolic functions, quadratic functions in absolute value signs. So this is going to be really interesting. And the one we're looking at is going to be negative x squared plus 2x plus 8. So the first thing that we're wanting to do here is we're wanting to determine the y and the x-intercepts. So let's do that. Well, the first thing that I'm noticing, okay, so I have negative x squared plus 2x plus 8. In order to find the x-intercepts, I know I have to factor this. So let's factor it. First, we're going to take out the negative sign. So we're going to have x squared minus 2x minus 8. Now we can factor this, right? And this is x minus 4, x plus 2. Okay? This, again, when you FOIL this back out, you get to the original function. So what does this mean? This means that x equals 4 and x equals negative 2. So those are my x-intercepts, right? X equals 4 and x equals negative 2. So when it comes to our original function, f of x, our x-intercepts are 4 and negative 2. What are our y-intercepts? Well, our y-intercepts are when x is 0. So let's just plug 0 in here. This is 0, this is 0, y is 8. That's it. What about g of x? Well, this works just like with line graphs. Our x-intercepts are going to be the same. They don't change. So 4 and negative 2. Our y-intercept is going to be the absolute value of the previous y-intercept, which again is just 8. So now we can sketch the graph. Let's do this. Let's start, of course, with f of x. So we have one x-intercept being 4 and the other x-intercept being negative 2. And we have a y-intercept of 8. All right, so those are the points that we know. Now, something that I want you to consider here is the fact that when we're drawing our parabolas, we often want to find our axis of symmetry. So where is that? That's right here. This is our axis of symmetry. So I'm going to draw that in. There's our axis of symmetry. Let's make that dotted, actually. Let's make that dotted. So again, that's right here. And we'll make that dotted. There's our axis of symmetry. Now, what does our axis of symmetry tell us? It tells us that anything to the left can be mirrored. So we also have that point. Now, we're missing a point here, aren't we? And we don't really know where it is here. So let's find it. What x value is this? X equals 1. So let's plug it into our equation. We're going to have negative 1 squared plus 2 times 1 plus 8. This would be negative 1 plus 2 plus 8, which is 9. So right there. All right. Now, I don't think we really need more points. I think this is enough for us. So let's go ahead and graph this. So this is going to come down through this point, and continuing down like that. Through this point. There we go. I'm making mistakes now. Okay, let's try this again. Through this point, and down. That looks pretty good. Okay, and this is my f of x. So what does my g of x look like? Well, my g of x looks identical when the y values are positive. So my g of x looks identical when my x values are positive, which means those ones are all the same. And when they're negative, they get reflected. So let's kind of just Just to be sure, let's find these values. So when x is -3, we're going to have negative 3 plus 2 times -3 plus 8. What is this? -3 is 9, so that's -9 minus 6 plus 5, which is going to be -15 plus 5, which is 10. Okay, -10. So that's -10. So we kind of extrapolated that. Actually, it worked out really, really well. So that's going to be up here 10 and up here 10. So now I just want to know exactly where we're trying to go to. So when this bounces back, it's going to go through that value of 10, like that. And when this bounces back, it's going to go through that value of 10, like that. And there's our absolute value function, g of x. So all I did is any values that were positive, they stay the same, and any values that are negative, remember, it's like a mirror of it, right? All these values become positive. So it just gets mirrored on the x-axis. So there we go. We have sketched the graph. Let's state the domain and the range. Now this is going to be interesting. Let's start with our f of x. So our domain is going to be x such that. Well, with normal parabolic functions, it's all real numbers, right? It's always that. It goes from -infinity to +infinity. And x is an element of real numbers. Okay. What's my range? It's going to be y such that y has to be less than, so you need your vertex for this. Y is going to be less than 9. Okay? So we are going to go from -infinity to x, and x has to be less than or equal to 9. And not x. Why did I put x? We're talking about y's right now. And y, of course, is an element of real numbers. All right, let's look at g of x. So our domain is the same. It's all x values are going to get hit here. So our x such that from -infinity to infinity, and x is all real numbers. And what's our range? Well, this one changed. So y such that. Now what happened? There's no negative values. So it's from 0 to infinity. So our smallest number is 0, and we can be equal to that, so greater than or equal to that, y, and less than infinity. And of course, y is an element of real numbers again. And there we go. We have our domain and our range. All right, let's take a look at D. Express this as a piecewise function. Okay, so let's take a look at our pieces first. Let's go ahead and highlight them. Let's look at this first part where there is an overlap. So you can see our f of x in purple and our g of x in green. They're overlapping. They look the same. So that's our first piece. Let's go ahead and write that part out. So we're talking about g of x. Y is going to be equal to, and then here we're going to put our two pieces. Our first piece is our original function, right? -x² plus 2x plus 8. So -x² plus 2x plus 8. So we're saying that g of x is going to look like our original function, -x² plus 2x plus 8, if what? Well, if x is in between these 2 points. What are these 2 points? There are x-intercepts, right? So 4 and -2. So if x is greater than or equal to -2 and less than or equal to 4. So if x is in between -2 or 4, then it's going to look exactly like the original function. That's the first piece. What's the second piece? Let's take out our highlighter and do a different color, I guess. Our second piece is this piece, right? And what happens here? Obviously, these pieces are not matching the original function. They're not matching the original function at all. Well, not at all. They're matching it, but all these values, the negative y values in these purple highlighted sections, have become positive in the light blue highlighted sections. So how do we say that? How do we say that our functions have become positive? Well, since all of our original values, so negative x squared plus 2x plus 8, so this is our original function. Our second piece is that these ones, all these y values in the original function have become positive. And we write that by saying it's the negative times the original function. So all these y values that are negative multiplied by this new negative out here is going to turn them positive. So that's the second piece. And this happens if, what? If x is less than -2 and if x is greater than 4. And there's my piecewise function. My first piece is this yellow portion, saying that it looks exactly like f of x in between -2 and 4. And my second piece is this light blue section, where I'm saying that if I take my normal function, which is the purple piece, and I multiply it by -1, it becomes the light blue piece. And that happens below -2 and greater than 4. All right, let's move on. Your turn. So go ahead and try this out. You have a parabolic function now. You're going to need to find the x and y intercepts, sketch the graph, state the domain and range, and express it as a piecewise function. Go ahead and try this out on your graph paper. Come back when you think you have the solution and you can check your work. See you soon. Okay, welcome back. We have the solution for you. So the first thing we were doing is we're taking this function and we're splitting it into two. So we have our f of x is the normal function and g of x is that function inside our absolute value expression. Now this x squared minus 3x minus 4, you can factor it into x minus 4 and x plus 1. That's going to give you two x-intercepts, 4 and -1. And of course, x-intercepts, as we've been seeing throughout the lesson, are the same for f of x and g of x. The y-intercept, on the other hand, is -4, and that means for g of x, it's going to be +4. So we can go ahead and graph these points. So we have our x-intercepts at 4 and -1 there, highlighted for you. And our y-intercept on our normal function is -4, and our positive function is +4. At this point, where do you go? Well, you should be trained by now to draw your axis of symmetry. So there's your axis of symmetry. Let's go ahead and erase those. So there's your axis of symmetry. And you can start mirroring points. So we can mirror that one. These ones are already mirrored, right? Now, how did I find this vertex? Well, I know if I look at my axis of symmetry, it's at 1.5. So plug 1.5 into your equation, and you can see in the calculator on the right that that's going to equal -6.25. So that gives me this point right down there. Now, what happens up above? Well, instead of -6.25, it's +6.25. So there, now I have multiple points on my graph that I can draw, right? This is going to allow me to draw my original expression, which is just a parabola, highlighted here for you. There's my normal f of x, right? And what happens when I take these negative values and I make them positive? You get your g of x, right? And what is that going to look like? Well, that's going to look like this. So these become positive, and there's your function. Okay, so what's our domain and range? Well, the domain is all real numbers, and that's for f of x and g of x. It doesn't change, right? For our range, we have a minimum value at negative 6.25. So y can be greater than or equal to that value and less than infinity. And it's, of course, an element of real numbers. For our g of x, it's a little bit different, right? We cannot be less than 0. So here we would say y is greater than or equal to 0 and less than infinity, of course. Now for our piecewise function, of course, we have two pieces here. We have this first piece here where our f of x and our g of x are identical. They match out perfectly, okay? And when does that happen? Well, that happens at the original function. So x squared minus 3x minus 4 was our original function. So g of x is going to look exactly like our original function when x is greater than -1 and less than -1 and greater than 4. So what we're saying with that is when x is less than -1, they're going to match. And when x is greater than 4, they're going to match. And of course, we can see that that's true. So that's what this says. Now, the second piece to this is that if you take the negative of those values, so making them all positive, g of x is going to look like the positive y values of our original function in between those 2 points. So it's going to be a reflection. So if I take all of these values that are negative and I make them positive, which is this piece right here, if I look at this piece, and this piece is created by taking our original function and making it positive, which is what this says. When does that happen? Well, that happens in between -1 and +4. And so when x is greater than -1 and less than 4, that is our second piece. And there you have your two pieces. That's it for today. Thanks for watching. See you next time. Thanks for watching, everybody. You can like, follow, and subscribe to my social medias to get notifications as soon as new content is uploaded. In the top corner here, you will find the playlist that this video is in. Watch the unit from beginning to end, and over here, you will find the next video in this unit. Keep learning, everybody. Take care.